This is an example of a unit circle. The unit circle, by definition, is a circle that has a radius of 1. We divide the unit circle into 4 quadrants. The first quadrant from 0 to 90 degrees, the second quadrant from 90 to 180 degrees, the third quadrant from 180 to 270, and the last quadrant from 270 to 360. Degrees increase as you move counterclockwise around the circle starting at 0 degrees. Negative degrees go clockwise starting from 0. You can express the magnitude of an angle in degrees, but another way you can do it is to express it in radians. 1 radian is equal to the radius of the circle wrapped around the outside of the circle. 180 degrees is exactly pi radians, and an entire circle is 2 pi radians. Given an angle measure, we can find the coordinates of any point on the unit circle. To find the height of the point, you take the sine of the angle, and to find the distance from the y-axis, or the x-coordinate, you can take the cosine of the angle. For any coordinate in the first quadrant of the circle, both coordinates will be positive. For coordinates in the second quadrant of the circle, the x-coordinate will be negative and the y-coordinate will be positive. For coordinates in the third quadrant of the circle, both coordinates will be negative. And for points in the fourth quadrant of the circle, the x-coordinate will be positive and the y-coordinate will be negative. We can also take the tangent of any angle of the circle, which will give us the slope of the corresponding radian. Tangents for 90 degrees and 270 degrees are undefined because they have no slope. As on any coordinate plane, lines that go up from left to right will have positive slopes, and lines that go down from left to right will have negative slopes. As you can see, the special triangles have distinctive coordinates on the unit circle. These coordinates apply to special triangles in all 4 of the quadrants, simply changing their signs depending on what quadrant they are in.